That smell of the sea after rain, the one you love so much, it's not the smell of water. It's the smell of death. Every time you stand on the shore and breathe in that salty, fresh scent, you are literally smelling the chemical scream of billions of dying microorganisms. And here's the strange part. That scream is quite literally what creates the clouds above your head. Right now, this exact second, somewhere in the ocean, trillions of single-celled organisms are dying. And their death determines whether it rains or shines tomorrow. Not just at the coast, in your city too. I'll tell you how scientists turned this discovery into a plan to save the planet from global warming. A plan so controversial that part of the scientific community wants it banned. But first, let's start with a single drop. Hey, last time we talked about algae. Today, we're talking about what happens when the ocean literally rises into the sky. We're going to trace the whole journey, from a single drop of seawater to the cloud blocking the sun over your house. Along the way, we'll cover why clouds technically shouldn't exist without the ocean, and that's not an exaggeration. What that scream of dying organisms from the intro actually is. How people are already trying to control clouds to cool the planet. And why some scientists think that if the ocean changes just slightly, the clouds above it could simply disappear entirely, and what that would mean for the climate. Deal? Then let's start with that drop. Picture a drop of water somewhere in the middle of the Pacific Ocean. It spent maybe a few thousand years here, traveling through deep currents. And now, finally, it reaches the surface. The sun heats it up. It gains enough energy to break its bonds with neighboring molecules and evaporates. It becomes invisible water vapor and rises. This isn't happening to just one drop. Every second, the ocean releases about 16 million tons of water into the atmosphere. Every single second. Over a year, roughly 500,000 cubic kilometers of water evaporate, enough to flood the entire territory of the United States under more than 50 meters of water. And here's the first fact that flips the usual picture. We're used to thinking of rivers as the Amazon, the Nile, the Volga. But the biggest rivers on the planet don't flow across land. They flow across the sky. They're called atmospheric rivers. These are narrow streams of water vapor moving through the atmosphere, several kilometers above the ocean's surface. A single one of these rivers can carry more water than the Amazon, the most voluminous river on Earth. Sometimes several times more. Atmospheric rivers regularly dump up to 50% of the entire annual rainfall on the U.S. West Coast in just a handful of storm days. Which means right now, while you're watching this video, an invisible river hundreds of kilometers wide is moving somewhere over the ocean, carrying trillions of tons of water toward the shore, and most people have no idea it even exists. Back to our drop. It keeps rising. The air gets colder. And here's a problem most people never think about. Cold alone isn't enough to make a cloud. The issue is that water vapor molecules have nothing to grab onto in clean air. They need a tiny solid particle, a seed, around which a droplet can start forming. Scientists call this a condensation nucleus. Without one, the air can be supercooled and oversaturated with moisture, and a cloud still won't form. The water just stays invisible vapor. And this is where life enters the picture. Remember that smell of the sea I mentioned at the very start? It's not just the smell of salt. It's a specific chemical compound, dimethyl sulfide, or DMS for short. It's produced by phytoplankton, the same microscopic algae we talked about in the last video. When phytoplankton comes under stress, attacked by a virus, eaten by zooplankton, or simply dying, it releases a sulfur-containing compound that breaks down into dimethyl sulfide. This gas rises into the atmosphere, where sunlight converts it into tiny sulfate particles. These particles become exactly the condensation nuclei we're talking about. Water vapor collects around them, forming cloud droplets. Which means, quite literally, part of the clouds over the ocean exist because trillions of microscopic organisms are constantly dying and exhaling a substance into the atmosphere that becomes the seed of a droplet. This phenomenon is the basis of what's known as the claw hypothesis, named after the initials of the scientists who proposed it in 1987. The hypothesis argues that ocean plankton can regulate Earth's climate. The warmer the ocean gets, the more actively plankton grows and dies. The more DMS gets released, the more clouds form, and clouds reflect sunlight back into space, cooling the planet. A living, natural thermostat that's been running for millions of years. To be fair, part of this hypothesis is disputed today. Later research suggests the connection may be weaker than scientists thought in the 1980s, and cloud formation is influenced by many other factors: sea salt, wind-lifted desert dust, volcanic emissions. But the core fact that living organisms in the ocean play a role in cloud formation has been confirmed repeatedly and is considered established science. And this is where the natural history ends and the human story begins. Because if microscopic organisms can control cloud formation and sunlight reflection on a planetary scale just by releasing a single gas, the obvious question is, can we do the same thing? On purpose? With our own hands? The answer already exists. It's being tested right now, in real conditions, not just in theory. And what's happening gives some scientists hope and genuinely worries others. This isn't a special effect. This is a real ship, on a real mission, happening right now off the coast of Australia. Scientists are building a fleet of ships that spray trillions of microscopic droplets of seawater into the air, day and night, artificially creating the exact condensation nucleus I just described. The goal? Make clouds whiter and denser so they reflect more sunlight, in an effort to save what's left of one of the largest living organisms on Earth. Some call this a rescue mission. Others call it a dangerous experiment on the entire planet's atmosphere, with consequences we can't fully predict. In a few minutes, I'll tell you exactly what this project is and why it's at the center of one of the sharpest debates in climate science today. The project is called Marine Cloud Brightening. It's being tested near the Great Barrier Reef in Australia. The idea is simple and bold at the same time. Special turbines mounted on barges spray extremely fine particles of sea salt, essentially recreating, in miniature, what phytoplankton does chemically. These particles rise into the low clouds above the reef and make them more reflective. A more reflective cloud lets less sunlight through to the water below, which means the water underneath warms more slowly, which means the reef and its corals get a better chance of surviving the next marine heat wave that might otherwise bleach and kill them. Pilot trials have already shown that clouds over the spraying zone do appear slightly brighter in satellite imagery. The technology works, at least locally. But this is exactly where the debate begins. Supporters say this is a temporary emergency measure for ecosystems that would otherwise die out in the coming decades before humanity manages to overhaul its energy systems. Critics respond, clouds are part of a massive, interconnected system of atmospheric circulation. Changing the reflectivity of clouds in one region could shift wind patterns, ocean currents, and rainfall in a completely different region, thousands of kilometers away. Modeling all the consequences in advance is practically impossible. This is the classic butterfly effect. Except it's not theoretical anymore. It's happening as part of a real climate engineering project. For now, the project remains experimental and localized, but the very fact that humanity is already physically spraying particles into clouds above an ecosystem the size of Italy shows just how far the idea of deliberately controlling weather through the ocean has already gone. Let's go back for a moment to our drop, or rather, to trillions of drops just like it. Sometimes the process of ocean evaporation spins out of control, quite literally. Hurricanes and typhoons need one key condition to be born: sea surface temperature above 26.5 degrees Celsius, down to a depth of at least 50 meters. When that condition is met, evaporation becomes so intense that a colossal amount of thermal energy, the same energy that was spent evaporating each drop, rises into the air. As the vapor climbs, it condenses into clouds, and that condensation releases the stored energy back out, this time as heat, which fuels the wind. A single large hurricane releases in one day an amount of energy comparable to several hundred atomic bombs, the size of the one dropped on Hiroshima. The source of all that power is simply the evaporation of water from the surface of a warm ocean. This is why a warming ocean isn't just the water got nicer for swimming. Every additional degree of sea surface temperature statistically means more frequent, more powerful hurricanes, because there is literally more fuel available for them. Meanwhile, the clouds of a hurricane are, in effect, a giant self-sustaining machine for pumping water and heat from the ocean into the atmosphere. The cloud shield of a large hurricane can exceed 1,000 kilometers in diameter. From orbit, it's one of the most recognizable shapes on the entire planet. And now, the most unsettling part. A huge portion of the ocean's surface is covered by a specific type of cloud, low stratocumulus clouds. They look boring, a gray blanket stretching for thousands of kilometers. But they reflect an enormous amount of sunlight back into space and noticeably cool the planet. In 2019, a group of climate scientists published calculations showing that if atmospheric CO2 concentration keeps rising at current rates, past a certain threshold, these cloud layers could become physically unstable and start breaking apart abruptly. The model showed that such a breakup could add an additional 8 degrees Celsius of global warming, on top of the warming already caused by rising CO2 itself. And this could happen not over centuries, but over decades, once a certain gas concentration threshold is crossed. To be honest about this is the result of one climate model, not a unanimous scientific consensus. Other studies estimate the risk differently, and scientists continue to debate how accurately this model captures the real physics of the atmosphere. But the very possibility that ocean clouds might not respond gradually, but instead flip between stable states like a switch, is taken seriously by climate scientists. It creates an almost eerie symmetry. We started this video with microscopic organisms whose death creates clouds that cool the planet. We're ending it with the clouds themselves, under certain conditions, potentially vanishing so abruptly that the planet could lose one of its main natural air conditioners. When we look at a cloud, we just see a white patch in the sky. We don't see the ocean that created it. We don't see the trillions of microscopic organisms whose death became the building material for a droplet. We don't see the invisible river of water vapor that just flew over the ocean faster than any airplane. The ocean and the sky aren't two separate things. They're one system, constantly flowing into itself. Water rises, comes back down as rain, flows back into the sea, and the cycle repeats over and over for billions of years. Maybe next time you look up and see a cloud, you'll remember that you're really looking at the ocean. It just decided to take a different shape for a while. If you liked how this topic unfolded through the story of a single drop, let me know with a like. I'll make more videos in this format. If you're enjoying this channel, you can now support us by checking out the description below.
In the comments, tell me, which fact surprised you the most? Atmospheric rivers, the scream of dying plankton, or the cloud brightening project at the reef? And if you want a full deep dive video on hurricanes or on climate geoengineering, let me know. We'll cover it. See you in the next one.